Hello. So, since the block for the runtime was way too fucking long, I thought, why not discuss the code myself? So, this would be a short video where I would be just discussing what's going on here in like very brief, and you know, I can deviate from this very brief thing. So, I don't know how it will go. So, let's see what happens. So, first, let me jump to the source and the main file, which is main.cpp. Here are all the header files. So first of all, we have child arguments. So the child arguments is a struct which takes, that's why it takes four things. First is rootfs. Now rootfs is our plain directory which has some user land things. It is discussed in very detail in very much detail in the blog, and it has the command which the container is supposed to run, and this start read and start write are just the end of the pipe pipe. No, there's a single pipe, so these are right end and the read end of the pipe. Okay, the child doesn't need to actually write anything, but it still gets the right end because it needs to close this end of pipe for itself, because here if we see in do run, we use, where did it go, here we just close the right end after making the right, but we use this clone system call. Yeah, we use this clone system call which makes the child inherit all the IPC primitives from the parent as well, so it inherits that right end. So the right end is also copied by the child and the child needs to close it. So we are closing it here in the child function, we are closing the right end, and after cloning, the parent applies limits. Also the parent sets the network up. Now, if the network flag is passed, then only the network class is instantiated. Otherwise, it is not, and that's why we use in place. Again, it's in very detail in the blog. Now, after these two happen, then only we close the right end of the pipe, and then only the child can proceed, and it can change the host name. Then it sets the rootfs up, then it makes an argument list for the exec vp function, so it should be null terminated strings. So for that we do this manipulation. So this is, I think, all about the run command in very brief. All the other code obviously is in the blog. Okay, so we check this, and the kill is also very simple. uh, it just sends a sig kill to the container and it is killed. But there are many edge cases in this, which again you can check. Now if we see how the file system is set up, it has 5 steps. First step is that we make the slash of the child private so that the host does not copy anything from the child after the mount table of the child changes. Then we bind the root fs directory to itself so that it makes itself a row on the mount table. Again, after that, we change directory to slash. Then we unmount the old root. Oh, sorry, did I miss this? Yeah, we just swap the old slash with something known as old root, and then we unmount this. and the new slash is the root fs. Then we just mount the slash proc and slash dev to the child. So this is all about the fs setup. Two more things which I'd like to talk about are, one is how we set up the C group. Now, C group means just how many processes can be in the container, how many, I mean, how much memory is the container allowed, how much CPU is the container allowed. So that is what. So we explicitly instantiate the constructor and make a directory for the C group. You can study about C group in detail, that it's just a directory in which we write these limits, and it's just a key value thing which we are doing here. And we make it uncopyable because we want to avoid double remove dir, so that nothing dangerous happens. We all know what double free or double remove dir cause. So yeah, then we just write the value in the file for the current key, which can be memory, CPU, or process PID. Then we add processes. This is also a helper. The most important thing is the destructor. When the destructor runs, the file is removed for the container, and the limits for this container, which is now non-existent, is no more a tombstone, so it is removed. That's it. That's so this pattern in C++ is called RAII, resource allocation is instantiation. So the name can be deviating, but it's just that when the class goes out of the scope, or when the resource goes out of the scope, the things, the resources occupied by this resource are also killed. The another thing is child stack. It is pretty simple. This the destructor for this is, we use a make unique call which allocates the space for the child stack on heap, and the destructor for this runs automatically for make unique. So this also follows the RAII pattern. Mm, After C group and child stack, I also want to discuss probably one of the most important things, which is networking. So to make networking work, we have to use something like a WETH, which is a virtual cable. So this command allows us to use it. And also we have IDs for every container, so that the subnet for the container host pair are different for every container which we run. And you can see the mechanism of using only one ID for one container and making all these work. So yeah, we were on WETH. So the WETH actually connects the host and the container end to end. Whatever goes in at one side comes out the other side. Second is, obviously, we are giving an address to both child and the parent, which is of the same subnet, so they can communicate with each other. Then we switch on the WETH. Then we do the same thing for the child, and we then, on the IP table, we add a post routing rule for the parent, that it changes the source of the request that come from the child to itself, so that the internet can serve the responses to parent itself, because the address of the children is not a real address on the internet. Before that, the parent or the host is actually a Linux system. It's not a router, so it does not accept requests which are not destined to the parent, so it drops those packets. So we can just simply switch this forward equals to 1, and it will accept those. And again, these are just your RAII pattern stuff. And then state, because PS requires state to learn about how the processes, about which processes are currently running. So that's why we maintain state of currently running containers. yeah, I think that's it. And I discussed it in very, very brief. But if you want the good niceness and niceties and very slow walk of this whole thing, you can obviously refer the blog. I took good 6 days to write the blog and do the code. So it will be worth it. And let me also know the feedback maybe. And I have a comment section on my website as well, which is very, very underutilized. I have only gotten one comment in like forever. So please utilize that. And yeah, that's it. That would be it. I might have made some mistakes, maybe not. I am not sure. So please correct me in the comments and maintain niceness, maybe. Yeah, that's it. Bye bye.